Good morning, guys. Happy Tuesday. Unfortunately, some of you are only going to get this lesson virtually this week. We don't have school tomorrow. On Wednesday with Veterans Day. So I want to teach you a little more. We're going to review what we were doing last class today, but I also want to go a little bit more into a function notation. So if I look at this, I do my vertical line test. I want to know whether these are functions or not. So I drag my vertical line, which I use my pencil. Does it hit my pencil more than once in two locations, here and here? Yes, it does. So this is not a function. When I do it with this one, it doesn't hit my pencil more than once in the same spot. So this would be a function. This one is definitely a function. Definitely doesn't hit my pencil more than once in the same spot. And then here, if I put my pencil on that line, it hits my pencil everywhere in the same location. So that is not a function. Now we're going to get into some stuff that's a little bit new. So if I'm looking here, this is called function notation. Functions can be written as rules to describe how the input values x change the output values, which are our y values. Functions also have their own notation. We call it function notation. This is our rule that y equals f of x. X is just whatever we put in those parentheses, but y equals f of x. So if I say, for example, if I say f of 2 equals 10, that means we have the point 2, 10. This is our x value, that's our y value. Okay, so when x is 2, y is 10. So looking at this function here, if they give me this function, f of x equals 3x plus 7, then they want to know what f of 2 is. All they want me to do here is plug a 2 into this equation for x. Then I do 3 times 2 is 6, plus 7, that gives me 13. So f of 2 equals 13. Okay. Next one, same thing, except now f is, we're doing f of negative 3, so x is negative 3. So we are plugging in a negative 3 right into this equation for x. That gives me negative 9 plus 7 gives me negative 2. So f of negative 3 equals negative 2. Going over to this one, very similar. I'm going to plug in a 20 now for x because it's asking me for g of 20. When they say g, if they change f to g, it's just recognizing this is a different function. That's all it's doing. So I'm going to now plug in 20 for x. 20 minus 6 over 2. I do 20 minus 6 first. That gives me 14. And then divided by 2 would give me 7. Over here, I can plug in a 0 for x in the same function. And that gives me a negative 6 over 2, which gives me a negative 3. Okay. I'm going to jump down to 4, so since it's closest to me right here. Same thing I was just doing. I'm going to plug in a 6 for x. I have to do this fraction first. 6 over 3 is 2, plus 7 is 9. So f of 6 is 9. Same thing. I'm going to plug that negative 9 into the same expression. Negative 9 over 3 is negative 3, plus 7 is 4. So that means f of 9 equals 4. Okay, now I'm going to jump over here. This one has a square root. Just so you guys know, you may have learned a little bit about this in 8th grade, but square root is pretty much the opposite of squaring something. So if I do 2 squared, that gives me 4. If I do the square root of 4, that gives me 2. So if I'm taking the square root of something, I'm asking what are 2 numbers that multiply to give me this number? So h of 4, and I'm just going to once again plug the 4 into this equation. So 2 times 4, plugging it in for x. 2 times 4 gives me 8, and then I have to add this 1. That gives me a 9. What 2 numbers multiply by itself give me a 9? 3 times 3. So square root of 9 would be 3. For h is 0, I'm going to plug in a 0 here into this equation. So it would be 2 times 0 plus 1. 2 times 0 gives me a 0. 0 plus 1 just gives me the square root of 1. The square root of 1, I'm just thinking what 2 numbers multiply to be 1. That would just be 1. Okay. Now over here, they're asking us some trickier questions. Take the function for number 4. So my function for number 4 looked like this. What input would make f of x equals 13 true? So really what they're asking here is when we have y equals 13, what would we need our x to be? So they want f of x equals 13 to be true. So they want us to get a y value of 13. So I'm just going to put a 13 in for f of x. And then I'm going to have to solve this equation. So the first thing I'm going to do to solve is subtract 7. That's going to give me 6 here. And then I have x over 3. I want to get rid of this denominator. It's division, so I'm going to do the opposite. I'm going to multiply by 3 on both sides. I get 18 equals x. So in order for f of x to equal 13, our input value x would have to be 18. Jumping over here, this one is definitely a challenge problem. So don't stress if you don't fully comprehend this one. But they are asking us once again to use the equation from number 4. So they're saying if g of x equals 2 times f of x is just another function. So they want us to use this function. So really all we're doing is replacing f of x with this function. So I'm just going to, instead of right next to that 2, instead of putting f of x, I'm going to put x over 3 plus 7. And then I'm going to still subtract that 1 right here. Now, that's all we had to do to put f of x into that equation. Okay, so this is g of x. What would g of 6 be? So now to find g of 6, I'm going to plug in a 6 where the x is. 6 over 3 gives me 2. 2 plus 7 gives me 9. And then 9 times 2 is going to give me 18, and then I have to take away 1. So my g of 6 would equal 17. Jumping to the next page here, things get a little crazier. We got a table. Boiling water at 212 degrees Fahrenheit is left in the room that is at 65 degrees Fahrenheit and begins to cool. Temperatures reading are taken each hour and are given in the table below. In the scenario, the temperature T is a function of the number of hours H. So our hours H is our input. Our temperature is our output, or our Y. This is our X. Okay, so evaluate T of 2 and T of 6. So they're saying, what would the temperature be at 2 hours? So at 2 hours, the temperature, T of 2, is 104. At T of 6, at 6 hours, what's the temperature? 68. For what value of H is T of H equal to 76? So they're saying, so T of H is the Y value. So they're saying output temperature is equal to 76. So when the temperature is 76, what hour are we at? So we're looking to find the temperature 76, that's right here. And what hour is it? 4. So we would just say H equals 4. Between what 2 consecutive hours will our temperature, our T of H is our output, so that's temperature, will our temperature equal 100? So I'm looking here and I don't see the exact value 100, but I see 104 and 85. So it must be between those 2 hours, and that would be hours 2 and 3. And if you wanted to explain that, you would just say the temperature at hour 2 is 104, the temperature at hour 3 is 85. So somewhere between the second and third hour, the temperature should hit 100. Now, if we take this to look at a graph, we can also identify inputs and outputs by looking at a graph. They're saying here f of 1. So they're saying that the x value is 1. Let's find the y. So I'm going to go to where x is 1 on my graph, and I'm going to find the y value. Looks like it's at about 6. So I would put a 6 here. Here they're giving us an input of 5. So that's an x value of 5. So I'm going to go to 5 on my x-axis, and I have a y value of 0. F of negative 3, they're giving us an x value of negative 3. So I'll go to negative 3 on my x-axis. My y value is at about 1. And then my f of 0. So when I have a x value of 0, my y value is at about a 5. solve each of the following for the input x. So now they're giving us the y value. So here they're just saying, y is 0, find me the x. So when y is 0, that's anything horizontal on the 0 line. So I actually see 1, 2, 3 possible answers here. You can have more than one answer, okay? If you have more than one answer for one of these, it means it's not a function. You can always have more than one answer for one of these. So right here is one answer. So I could say that x equals 1, 2, 3. It looks like we're a little less than 4. So I would say maybe x equals negative 3.5. X could also equal, right here we're at 5. And x could also equal right here, which is at about a little over 7. So maybe we'll call it 7.1. Okay, and we're just approximating there. The next one says, if y equals 2, what would our x be? So when y equals 2, that's about here. I'm going to look horizontally. It happens here and here. So this would be at negative 2 on my x-axis. And this one here would be at 2, 4. So those are two different options for x's that we could have when y equals 2. Lastly, what's the largest outputs? Outputs of the y value. So what's the largest y value? The highest y value we get up here, or the largest, is that 6. So our largest y value is 6. At what x value is it hit? So what x value is that? It's at x equals 1. Okay, so this is just a little insight into our function notation. Today you're going to work on this packet. I'm going to give you guys until next Sunday night to finish this packet. So if it takes you some time, that's okay. But you want to think about, is it a function, and give me the domain and range. Now, there is something we have not talked about yet that is on here. So I'm just going to touch on a few things that I think we might not have talked about. So this first one here is set notation. So if I have what I call a continuous graph, that's this, or these. Continuous means I have a continuous line. I also could have a discrete graph. So a discrete graph is something that looks like this, like a bunch of dots. It also could be a table like this, a bunch of points. Those are discrete. I can't tell you that from 6 to 7, I can't tell you from negative infinity to 12 is my domain. It doesn't work like that because it's not continuous. There's no line. Instead, I can just list you off numbers. So I can see right here that if I put my pencil here, there's not 2 dots here, not 2 dots here, not 2 dots here, there is. So this is not a function because these two values have the same x value, two different y values. So that's not a function. This one, however, that does not happen. So this would be a function. The domain and range here, I'll leave this one for you to try on your own. This one, the domain, you just want to count those x values and put them in a set. A set has these little squigglies, and then there's commas between each point. So the x value for domain, this looks like it's at negative 3. And this point is at negative 1. This point is at 1. This point, they're both at 3. And you don't have to repeat that 3 even though there's 2 points. The range, we're going to look at all their y values. So the smallest y value I have is here. That's at about negative 2. Then this one's at negative 1. This one's at positive 1. Nothing here. These are both at positive 3. And then I have 1 at positive 4. If it's hard for you to identify that from a graph, you could go ahead and write those points out if it's easier for you to look that way. You could list out all the points, but that's a lot more work. So you could name each point. So this would be like negative 3, 3. And then you could list them all out and then write down your x values and your y values in 2 separate sets. These we've practiced a lot, finding the domain and range. I think we're okay. These, once again, you have x values and y values. So you want to see if you have two of the same x values, that would make it not a function. If you have two x values that have different y's. I don't see repeating x values, so I think we're okay. This is a function. Now the domain is my x values. I want to go from small to large. So the smallest one is a 0. So I'll start with a 0, then a 1, and then 4, and then 7. Range is my y values. So my smallest y value is this -9, then the -5, and then 0. I don't need to put 2 zeros. I can just put it once. Okay. We just talked about how to do these. So they're saying evaluate the function when x is 3. You're just going to plug in a 3 and solve. You got to do it for 0, and then you also have to do it for -2. So you should have 3 answers for all of these. This we just worked on. We just worked on this. This one, they just want you to tell them the error. This one, we're doing out a rule. So if they say x is -1, they give you this function. They want you to plug that -1 into the function and find our output. Okay, so you would do this workout. 10 minus -2 plus -1. I'm sorry, times -1 is going to be 10 plus 2. That's going to give us 12. So your output would be 12. Okay, so fill out the next two. This one, they're giving you two different functions, an f and a g. So just pay attention here to whether we're working with f or g to know which function you're using. Then we got some from a graph, which we just worked on, and we just worked on this stuff. So you guys should be good from here. Please reach out if you have questions. You can get extra help on Monday if you need it. All right. Have a great day, guys.